Hello students, welcome in another session of 12 Computer Science Paper 2. Already we have started chapter 2 in paper 2. So let us proceed. Second chapter, instruction set and programming of 8085 microprocessor, session 20. Student, in this video I am explaining next group in 8085 instruction, that is machine control group, and this is the last group in this chapter. Before that, only one instruction is remaining in branching group, that is PCHL. Okay, now see for this instruction, then we will start the machine control group. Now see, PCHL means, see what is PC? PC means program counter, HL means register pair. Okay, PCHL means load register counter with HL, means whatever contents in HL register pair that directly stored in program counter. Now see the format. See, H contains transferred in program counter in higher byte. First transfer higher byte, then transfer lower byte. Whatever contents in L register that contains loaded or transfer in program counter. Addressing is register addressing. Why register addressing? Because here only registers are used. Group, branching group. Byte is 1 byte. Why 1 byte? Here this PCHL only 1 byte is required to store the instruction in memory location. Why 1 byte is required? Because here no 8-bit data are specified, or also not specified 16-bit address. So here only registers are available. So these instructions required only 1 byte memory location. Flag, no, means no flags are affected, because here only data will be transferred one location to another location. Nothing any calculation. So here no flags are affected. Now see how to execute this instruction. This instruction moves the content of register H to higher order byte of program counter. Program counter is a 16-bit address. Okay student, program counter is a 16-bit address, means H is 8-bit data stored and L is 8-bit data stored. Total is 16-bit data are stored in HL register pair, and that 16-bit data transferred in program counter. Only separate by higher and lower. In HL register pair, H is higher register, L is lower register. Student, one thing is remember, in PCHL instruction only HL register pair is used. No any other register pair is used like BC or DE, because here only HL registers are used. Okay, this thing is always remember, and whatever HL register contents are stored, that content transferred into program counter. Okay, now see, this instruction moves the content of register H to higher order byte of program counter, and the content of register L to lower order byte of program counter. Means this HL higher and lower order byte are transferred into program counter. Now see the example. Let H contains 23H and L register contains 45H data. Okay. Now means H and L register contains 23H and 45H respectively. Now instruction is PCHL. After execution of these instruction, means PCHL, program counter contains 2345H data. Understood student? Got it? Whatever contents in HL and L register, that both contents are stored in program counter. So after execution, PCHL instruction program counter stored 2345H data. Means PC is a program counter, and now program counter means it is also known as memory location. I think in previous session conditional or unconditional jumping instruction, call or return instruction, already I explained program counter, how to execute or function of program counter in detail. If one by one instructions are executed in assembly language program, starting address stored in automatically starting address stored in program counter. If one by one instructions are executed, then automatically program counter increment by 1. Okay, means next instruction, whatever address of next instruction, that address automatically stored in program counter. Means what is the function of program counter? Program counter stored the memory location where the program is stored in memory, starting location of program, and automatically it will be incremented by 1. Okay, understood this instruction PCHL. Now branching group will be completed. Okay, now next group we start machine control group. In machine control group, all instructions are related to stack. I think all students are very well familiar with this stack word. Okay, because the stack word in already seen in data structures. Okay, last topic in data structure, that is stack and queue. Okay, so same function will be same. Anywhere in programming language stack word is coming, that function should not be changed. Okay, always remember, just syntax will be changed, but whatever functions, mean whatever structure of stack, that will be same. Now in machine control group, all instructions related to stack. So before that we will explain these push or pop operations related to stack. What do you mean by push and pop? Okay, now see first operation in stack, that is, first see what is stack. Means stack means the stack is a part of read write memory that is used for temporary storage of binary information during the execution of a program. Okay, what is stack? Stack is a temporary memory. It stores the memory address, but it not stored permanently. It is a temporary storage device. Where to use this stack? This is also seen in previous sessions in conditional or jump instruction. When conditional instructions are used, the next address stored in this stack operation, in this stack, that is a temporary storage, and again jumping instruction will be completed and program counter again back to main program. At that time, that whatever address stored in stack operation, that address going to in program counter. Means what is the function of stack operation? Stack means to store the memory address as a temporarily. Okay, and stack is a 16-bit address like as a program counter, and so it is also called as read write memory. Means in stack also write the operation, also read the operation. For the application, now see what is the main purpose of this stack. For the application of programs, mean when writing the assembly language program, at that time if internally memory of the microprocessor, means internally memory means where to store the data in 8085 microprocessor, as a register. Okay, register we are used to store the data. So data and program stored in a memory location. This is a first listen, program stored in memory location, but data stored in register. Okay, the internal memory of microprocessor is not sufficient to store the intermediate result. Now see what do you mean by these intermediate results? Intermediate result means temporarily stored data, means just like if we are use subroutine or you use conditional jump instruction, at that time where the stored next location in main program, at that time stack operation is used or stack is used. This intermediate, it is called as intermediate results, means it is a temporary storage. These intermediate results can be stored temporarily on the stack and can be referred back when required. Means when required, that result or that data at that time stack again back to in that stored, whatever stored in stack, that stored data transferred in program counter. Okay, this is the main purpose of stack. Stack, two types of operation for stack. First is push. When the information is written on the stack, the operation is called push. Means whatever write in onto the stack, it is called as push. And pop, opposite of push, means when the information read from stack, the operation is called pop. Means if you want return in stack, then push operation used, and if read from stack, the pop operation is used. Okay, student, on this topic in board exam for 3 or 4 marks, ask the question what is stack and explain stack operation in 8085 microprocessor. At that time you can write these operation push and pop, explain with proper example. Now see detail how to execute push and pop operation in diagrammatically. Okay, now see first operation is push. Push means return on the stack. Okay, now you know structure of stack. See, in push operation 16-bit data is stored in the stack. This 16-bit data is stored in two operations. See, why two operation? Because 8085 is a 8-bit microprocessor and stack pointer is a 16-bit data is stored in the stack, as same like as a program counter. Now see stack. Okay, this is the structure of stack. One and stored in this memory location. Starting memory location is 2001, then 2002, 2003 and 2004. One end is open, other end is closed. Okay, this is the structure of stack. Okay, already this topic we have seen in data structure operation. Okay, now see, now in this stack pointer at 2004 memory location, this is the initial position of stack pointer. Now after some data or whatever any data stored in stack pointer, now first this is a 16-bit stack pointer. Okay, now see how to execute it. In the first operation, in stack operation push or pop, there are two operations. Why two operations? Because at a time 8-bit data are stored in one memory location. Because in 8085 microprocessor stored only 8-bit data. So here also if we want to store the 16-bit data, that 16-bit data divided into 8-bit and 8-bit. So first 8-bit stored in separate memory location and another 8-bit stored in another memory location. So here two operations are required to store the data in stack pointer. Now see, in first operation stack pointer is decremented by 1, and then the higher byte of the 16-bit data is stored at the memory location pointed by stack pointer. See, this is a main word. Stack pointer is decremented by 1. When data is stored in memory location, at that time stack pointer is decremented, not incremented. You maybe think when data is stored, then memory pointer is incremented because data is stored. Okay, but see here, data is stored. This stack point, this memory location starting from 2001, 2002, 2003 and 2004, and stack pointer where in first initial position of stack pointer where it is at 2004. Why 2004? Why here not 2001? Because stack pointer one end is closed, another end is open. Means whatever data stored in stack pointer always stored at one end and also pop or read from one end. Means whatever data stored in stack pointer then goes to last position, then after that, then after that, then after this. So whatever data stored in stack, then stack pointer decremented by 1. Okay, now see diagrammatically, this is the stack. Now stack pointer is at initial position in 2004. Now after first operation means higher byte is stored in stack pointer, means stack pointer now becomes at 2003 memory location. See here, stack pointer where? At 2003 memory location. Initial position of stack pointer is 2004. After first operation, higher byte is stored in stack pointer, then stack pointer is decremented by 1, that is it goes to 2003 memory location. Now this is a decrement. SP means stack pointer, decrement stack pointer and store higher byte. Now at second operation, again stack pointer is decremented by 1, and at that time lower byte of 16 bit is stored at the memory location pointed by SP. Mean whatever data in lower address or lower register, that address or that data stored in next memory location, means decremented by 1 stack pointer. Okay, now see in diagrammatically, this is the stack pointer, same diagram. Okay, now in second operation, after executing this is first higher byte is stored, now lower byte is stored also, then first higher byte is stored at 2003 memory location, now store lower byte, then stack pointer again decremented by 1, means stack pointer goes to at 2002 memory location. First stack pointer 2004, then higher byte is stored, then goes to 2003 memory location, then again stored lower byte, then goes to 2002 memory location, means at 2002 memory location store lower byte. Okay, now what is the position of stack pointer? Now after second operation, stack pointer now becomes at 2002 memory location, means here again decrement stack pointer and store lower byte. Student, see initial position at 2003. After two operations, mean after store the higher and lower byte data, stack pointer now becomes at 2002. Means starting is 2004. Now after store the data, stack pointer it becomes at 2002 memory location, means stack pointer is decremented or incremented? Decremented. How much? At 2 position, means 2004 to 2003, 2003 to 2002, means 2004 minus 2002, means it becomes decremented by 2, means when data stored in stack pointer decremented by 2. Understood, student? How to store the data in stack pointer? So when data stored in stack pointer, means push operation is used, at that time stack pointer is decremented by 2. Why stack pointer is decremented by 2? Because 16-bit data divided into 8-bit, higher 8-bit, lower 8-bit. Okay, because whatever data stored in address or in register, suppose BC pair is used, then whatever data stored in B register, B is higher, C is lower. Then whatever data stored in B register, first store the B register data, then store C register, like this. Okay, suppose address will be stored 6070, then 60 is higher byte, then first store 60, then store 70, because 70 is lower byte. Okay, any type of operation, any type of data you can store in stack pointer, but data is stored in memory location, only 8-bit data stored in memory location. Okay, now see next operation, pop. Pop means read data from the stack. Pop operation means 16-bit data is read from the stack. Means whatever data stored in stack, if you want that data read or you want to pop the data, then how to do it? See, this is a stack. Now initial position in pop operation. See, in previous push operation stack will be empty because data is returned into the stack, but in pop operation already data is there. Means pop operation means read from the stack. This word is very important. Read from the stack means data already stored in stack. Now see, this is the initial position of stack. Now in initial position stack pointer, where it is at 2002 memory location. Now I want to read this data. Okay, I want to read this data. Now initial position of stack pointer is 2002. I want to read this data, lower or higher byte. I want to both data or suppose higher byte I want to, then first read or first pop the lower byte, then higher byte. Okay, because one end is close, always remember. Okay, now see first operation in pop, the content from the memory location pointed by stack pointer are loaded into the lower byte of register pair, and then stack pointer is incremented by 1. Okay, means whatever data stored in memory location, first lower byte, and then at that position or at that situation stack pointer is incremented or decremented? Incremented, opposite of push operation. Now see diagrammatically, this is the stack pointer, where it is starting position of stack pointer 2002 memory location. Now first pop the lower byte. Okay, now after pop the lower byte, stack pointer becomes at 2003 memory location. Okay, means see 2003 to 2002 to 2003 means stack pointer is incremented by 1. So here increment stack pointer and store higher byte. Sorry, here write pop lower byte instead of store higher byte. Okay student, delete this statement. Pop lower byte. 1 minute. See, store higher byte instead of this here pop lower byte. Okay, now next is see, in this diagram 2000 to 2003 means stack pointer incremented by 1 because lower byte is read from the stack, means out of the stack. Okay, now in next operation, in the second operation, the contents from the memory location pointed by stack pointer and loaded into the higher byte of register pair. Okay, now see here, In second operation, higher byte is pop up, means read the higher byte data from this stack. Means in second position, first operation, stack pointer at 2003 location. Now in second operation, 2003 to 2004. Now stack pointer at 2004 memory location after read lower and higher byte. Means student, see here, increments again stack pointer by 1, and same here, instead of here store lower byte, here pop higher byte. Okay, pop higher byte. This is typing mistake. Understood? Means student, in pop operation, stack pointer is incremented by 2. See again, initial position of stack, lower and higher byte is stored, stack pointer at 2002 memory location. Now in first operation, first lower byte is read from the stack, then stack pointer is incremented by 1, means at 2002 2003 memory location, means stack pointer now becomes at 3 position. Now again next operation, higher byte is read from the stack. Now at higher byte 2003 to 2004 memory location, means in first and second operation 2002 to 2004. Okay, means stack pointer is incremented by 2. Understood? These two operations in stack pointer or stack operations, push and pop. These are the two operations of stack. Push means return into the stack, pop means read from the stack. Stack is a 16-bit data can be stored, but in diagrammatically 8-bit it is divided into 8 and 8-bit. First stored higher bit, then stored lower byte. Okay, understood student? Okay, thank you.